delete operation. So in a linked queue, we will do the delete operation in the friend position. So in a friend position, we will do the delete operation. So before doing the delete operation, we need to check one condition. That is, we need to check friend is equal to null. We need to check the condition friend is equal to null. So why we are checking this condition? If any node is available, then only we can able to do the deletion. If the queue is empty, means the no deletion is not required. Okay, so before doing the delete operation, we need to check friend is equal to null. Okay. To delete the element, what we are doing, first we are checking the condition friend is equal to null. If this condition is false, means then we will do the delete operation in the friend position. So this is the friend position. So what we will do, the next node will become as a friend position, and by using the free function, what we are doing, we are removing the node from the linked queue. Okay, so what we are doing, we are changing the friend position. So the next position, this become as a friend, and we will remove this node from the queue. So here the friend in a friend position, we are doing the delete operation. So this is the code. So we are declaring the pointer star ptr. Then we are checking the condition friend is equal to null. If it friend is equal to null, means the queue is empty, so it will print the message as the underflow and it will return. If it is false, it will go to the else part. And what we are doing, we are making this friend as a ptr. Okay, we are making friend as a ptr. Then friend tends to next, friend's next address, what is having the next node. So we are making this as a friend now. Okay, this node is a friend. Then by using the free function, we are removing this node ptr node from the queue. Okay, so what we are doing, first check we are condition. The condition is true, means it will print the message as the underflow. If it is false, what it will do, it will go to the else part. And here we have given ptr is equal to friend, so we are making this friend node as a ptr node. Okay, then friend is equal to friend tends to next, we are making next node as a friend, and by using the free function, we are removing the ptr node from the queue. Next we will see the code and algorithm. So this is the algorithm, the same what we saw in the code. So first we are checking friend is equal to null. Then we are printing the message. If condition is true, means we will print the message as the underflow, and it will go the step 5. Then next in a step 2, what we are doing, we are checking the condition ptr is equal to friend. Okay, we are checking the condition ptr is equal to we are assigning ptr is equal to friend. So what will happen, the friend node become as a ptr node. Then by next function, friend is equal to friend tends to next. So what we are making, we are making the friend next node as a friend. Then by using the free function, we are making. So you can check the else part, both are same, and here checking the condition. Okay, so we will see the full code for the linked implementation of queue. Okay, so whatever code we saw for the insertion and deletion, that will be given here. So first we are declaring the structure node, and inside we are declared the member as a data and the self-referential structure pointer as a char next. Then we are declaring the pointer structure variable friend and the rear. Then we are defining the functions, insert function, delete function, and display. Inside the main function, for displaying options, we are using the switch case. So for getting the choice, we are declaring one variable choice, and here we are checking the condition choice is not equal to 4. So if it is any one of the choice, means it will do, otherwise it will come out of the switch case statement. And by using the printf statement, we are printing main menu. Then 1 is the insert an element, then 2 is an element, 2 is a delete an element, then display the queue, then exit. Then what we are doing, by using the printf statement, we are printing enter your choice, and by using the scanf statement, we are getting the value of the choice. And this is the switch case. So for case 1, we are giving insert. So if you are giving the here, for choice, if you are giving the 1, so what will happen, the insert, this function will be called, insert function is called. So what it will do, it will go to the insert, this is the function definition, and here what we have done, the same code what we saw in the insert. So first here we are declare the pointer variable, then we are declare one integer variable item, and for this pointer we are allocating the memory space by using the malloc function. Then we are checking the condition ptr is equal to null. If it is equal to null means it will print the message as the overflow. That means the queue is full. Okay. If not, it will go to the else part, and what we are doing, we are getting the value for the new node. So, and we are storing in the item. Then in a ptr already we have allocated the memory space by using the malloc function. So if now ptr tends to data is equal to item. So in a new node, okay, so consider this is a new node. In a data part we are storing the value. For example, if the item value is if 8, and next we are checking the condition friend is equal to null. So why we are checking the condition? If the friend is empty means we are going to add the new node, right? So we are checking the condition friend is equal to null. If it is equal to null, if this condition is true means the particular queue is empty. So what we are doing, the new node we are making as a friend, and same time the new node ptr node is a rear, and in that particular nodes next what we have to define. So this is the new node, after that there is no node, so we have to give as a null. So it is given friend tends to next is null and rear tends to next is also null. Suppose this condition is false, it will go to the else part, and here rear tends to next is equal to ptr. So in a queue what we have to do, we have to insert the new node in the rear end, right? So we are inserting this we are inserting the new node at the rear end. So rear tends to next is a ptr. Then we are making the rear is equal to ptr. Ptr node is rear now. Then what we are doing, rear tends to next. So it is the last node. After that the node is not available. So in address part we are making as a null. Okay, and next if you are giving the option as a 2, the choice is a 2. So what will happen? It will call the function delete. So this is the delete definition. So here we are declaring the pointer variable and checking the condition friend is equal to null. If it is null means it will print the message as the underflow. If not, it will go to the else part. And what we are doing, we are making the friend node as a ptr. Then we are making the friend node's next node as a friend. And by using the free function, what we are doing, we are removing the particular node from the uh, queue. And next, if you are given the choice as a 3. So what is the choice 3 here? Displaying the queue. Okay, the choice 3 is displaying the queue. So this is the definition for the display. So we are using the pointer variable, and what we are doing, so from the friend position it will start printing the values. So friend is equal to ptr, and we are checking the condition. So if you want to print the node, if you want to display means some nodes should be there, some data should be there. So we are checking the condition friend is equal to null. If it is equal to null means it will print the message as the empty queue. If not, it will go to the else part and it will print the values, and it will check the condition while ptr is not equal to null. Okay, it will check the condition ptr is not equal to null. So till this condition getting false, what it will do, it will print the values. Okay, so if the condition is true means it will go inside the loop and it will print ptr tends to data. So which node it is pointing, it will print the value. So for example, so here you can see the values we have inserted the element. So it is 2, 4, 6, 8, okay, and 5. Okay, and we are printing the values here. So it is the rear position. So from the 2 we have started, and this is the front position. So this is the front position and this is the rear position. So now what is the ptr node? So ptr node, okay, so we are checking ptr tends to next. Okay, we are checking ptr tends to next. So sorry, we are checking ptr is not equal to null. If it is not equal to null means what it will do, so this is the ptr node now. So ptr tends to data. So what is the data? It is 2. It will print the 2. Then what we are doing, we are making, so this is the ptr here. I will represent here ptr. We are printing. Next what it will do, it will, the ptr node will move to the next node. So here this next node. Then we are checking the condition, this null. It is not null. So what it will do, it will print the value 4 and it will move the pointer. So like this way it moves. So till 5 it will print the value. So 2, 4, 6, 8, 5. So after the 5 there is no element. So what it will do, condition becomes false and it will stop the execution. And here we have given one more choice, it is a 4. So when I giving the choice as a 4, it will exit from the loop. So this is about the queue implementation using the linked representation.